All right. So in this lecture, we talked about design patterns. When professional works on problems, they usually start to see many of the similar problems over and over again. So then they would develop a set of techniques or procedures or method for solving some of the problems, and these in turn might be collected or passed on, or maybe these techniques are taught throughout schools or their own institute or companies, and then these become patterns, and then these patterns are a collection of methods that can be used to solve a particular problem. Okay, and you can see a bunch of patterns like this in most of the professional area, like in carpentry, engineering, software engineering, and mathematics, science, in the sci field. They all have this kind of like patterns for solving a set of particular problems. Okay, we as software engineers, we also have a bunch of problem and patterns or a method for solving this problem as well. Okay, like data structures are also patterns, right? We want to keep some data in some way so that you can do something with it. And if you see it more often, we can, someone just develop this particular like linked list or data structure for doing something, right? So these are patterns as well. Okay, but in software development, recently, not that recent, maybe in the last 20 years, people start collecting patterns for solving many problems, and in many levels of software development. We will look at design patterns, but I would quickly go over some of the patterns that you see in other areas like UI. Right, when you look at UI, right, the fact that you can pretty quickly understand this hamburger menu, like when you see it, like if you click on it, you see a drop down menu, right? And if you understand this, if you click here, it would pops up some menu. This is the button you can click, right? And like on this menu, you can see if you click here that there's a menu inside, and you can have a menu on the left and the right. This is a drop down, you can search, and this is a navigation bar, right? So you can do all this because this is the pattern that you are kind of like familiar with, right? So this is the pattern for the user interface. If you want a user interface that doesn't look like this, maybe the user might not get that familiar, right? But this is not just something familiarity, right? The reason that you use this hamburger menu is because there's a problem with it, right? There's a problem that you have to solve. Like, for example, you don't have enough space to show the menu, right? Because on the mobile, your phone has very limited screen width, screen real estate. So you need to collapse something, and then you say, okay, it's collapsed here. It's a hamburger menu. And also this one, like if you have a bunch of screen space, you can use navigation bar like this, right? But the fact that you put it here so that user can see and click pretty quickly, this is also something that the UI designer used to solve the problem, right? The user would like to navigate from here and there in the website quickly, so they put a really shortcut menu on top, right? So the fact that you get to see this pattern is because there's a problem and there's a way to solve this problem nicely, and then people start, you know, copying each other. Then you see this thing everywhere, right? So the first time it appears, it's a solution. When you see it fairly often, it's a pattern that people use. In software architecture, later on you learn a bunch of names like this: layer architectures, like all microservice architectures. So these are the way people organize their modules, their big software, right? So they have many layers, like database at the bottom, the view layer, React, and this is like API layers. So these are the way they organize you know, the modules in their enterprise software. So this is called layer architecture. It's a kind of pattern as well. Or you can, maybe later on you hear about microservice architectures. This is like you divide really big work into smaller service. They are all independent, and then you can let them call each other. So this is also a pattern. Now let's go ahead and talk about design patterns. Okay, so this is the book that pretty much start everything. Previously, there are the books that collects pattern for like architectural designs, like in architecture, like buildings, stuff like that. But this is the first book on software development. It is usually referred to as a gang of four book because there are four people here, right? Gemma, Helm, Johnson, and Mercedes. And they present 23 classic design patterns that are categorized into 3 groups. Creational patterns, this is how objects are created. These are pretty much patterns for object-oriented software, okay? So if you look at other paradigms like functional programming, maybe you see other kind of patterns, but we would pretty much focus on object-oriented designs, okay? So they present 23 classic design patterns that can be categorized into 3 groups: creational patterns, structural patterns, and behavioral patterns. We will later on see what each of these categories is for, but to quickly summarize, creational patterns is how you create objects. Structural patterns is like how you structure how the object interacts with each other. And finally, behavioral pattern is you know, solve the problems with how objects behave with each other. Okay, so when you look at design patterns, it's a book. Like this one is a book, and there are 23 classic design patterns. You see more and more patterns. So how are we gonna approach these design patterns? So it's not like you should go ahead and try to memorize all the patterns. It doesn't work that way, okay? I think the nice example of how to approach the catalog of design pattern is like to think about like when you play a game, okay? When you play a particular games that has a lot of characters and each character has skills, you're not gonna go ahead and, you know, try to memorize everything, right? So that you can play the game well. That's probably not the way to do it, okay? You might want to look around a little bit to see the characters and how they works, like skim all of the information there. And then when you start playing some of the characters, you look into the details and you learn the advantages of this character and the weakness, right? The strengths and the weakness of the characters that you would like to play and of some other characters. This is how you deal with catalog of characters in some of the games, right? It's how you would work with design patterns as well. Today we're gonna look at some of the patterns. We'll look at some of the pattern in details, okay? We'll look over many of the patterns, but we're not gonna try to remember all of that, right? So we will try to get a sense of what they are trying to solve, and when we need it, we'll use it, okay? And we have already used some of the patterns, okay, as we will see later on, okay. When we developed the Gorilla games, we used two of the patterns from game programming patterns, okay. The first is the game loop and the other is update method. So the patterns of game loop is that you can look at this website, okay. We'll look at this this book, Game Programming Patterns, pretty soon, but it gives you the rough overview of the patterns that we will look at. So this is the website. We look at that. It's good because it gives you the complete book on the web. But if you are interested, you should buy it. Okay. So we have been using both game loop and update method. Okay. When you look at the pattern, when you want to read it, there's an intent. So that's the goal for the patterns, and motivation. Usually start with the motivation and then the actual patterns and then some other stuff, right? We'll look at that later on, but these two patterns are the patterns that we have already used. Okay. The game loop patterns is like we have a loop that look at the input and run the update, right? Update all the game states and render the everything on the game. So this appears now our game framework as function animate. Okay, it look at all the sprites or all the elements, right? And then we call update on it. We update its states and we render. Okay, and then this self.after register another call to this function. So it would act like a loop here. So in a game you have this loop. It's a core of the game. This is to call the game loop patterns. Okay, so we use that. Okay, using this kind of like patterns allows you to like when you look at a game usually consists of many objects with many difficult independent behavior. So if you don't organize your game into like a set of objects and do the game loop like this, it would become extremely difficult to deal with when you have many objects. Okay, so this is the patterns. The problem that it tried to solve is to organize the input, output, and state update of the game. The other patterns that we've used is the update method. Okay, so this pattern basically every object in the game needs to update its states. But how are you gonna organize the state update procedure for every object? The update method patterns tells you that you should implement the update method for each of the objects, and this update method just work by just simulate the behavior of the object by processing one frame, just one step. You do not try to update you do not try to compute the trajectory of the banana from the beginning, but we're not gonna do that. We'll just simulate just one step of its behavior. Okay, by putting this update method patterns together with the game loop, you have a way to structure your game pretty nicely, okay, into this update and the main game loop. Okay, so this is the pattern that we have already used. Now let's look at what's in the pattern, right? When you want to read a pattern, you need to usually a pattern describe the problem and the solution and also the intent. What the intent is like is the why of the pattern. You want to know why you would like to use this pattern. Okay, maybe there are some other additional information like motivation and when to apply this pattern, when not to apply, cautions, and sample codes. So when you look at patterns, these are the things that you need to look for. So we learned a little bit about the patterns and we've seen some and we used some. How are you going to apply design patterns in your code? I think there are two directions. We would mostly focus on the first direction because we are really beginners. So we would use design patterns as a way to solve our problem. We usually start with the messy code. We know how to do stuff, but we don't see how to do it in a nice way. Okay, so we usually start with a messy code, and then we look at the patterns, and we look at the available pattern and use it to improve our code. Okay, after a while, when we get a sense of what's good and what's bad, we might before developing the software or writing code, we might start by looking for a good patterns that we would like to use. So we would see the design problem beforehand, and then we use the pattern to come up with a good design and a good code. So that's the next step when we are kind of like experienced. We would do both ways, but typically we would start as the beginner, right? We might write some bad code and then improve it to get a good code. Okay. To read the pattern, sometimes you need to understand this modeling language. Okay, this is called UML Class Diagram. The pattern usually describe how objects interact, and the way they do that succinctly is to use this kind of like diagram language called unified UML. Okay, so basically you have a set of classes, and then there are relationship between classes, so that when you look at this relationship, you understand a little bit how thing works. Like, for example, if you look at this part, so this is a class called creator, and this is creator 1. Okay, this arrow, this symbol says that creator 1 is inherit from that class. This is an abstract class. Okay, so you have a class called creator, and this is the actual creator. Okay, this one is an abstract class. It's like it provides a template for you to for a creator, and then this is a real creator. Okay, and this real creator has a factory method that you can call to create some stuff. Okay, so this creator would create a product, and then this tell you this is an abstract creator that would create a product, and this is actual creator. So when you want a kind of creator to create something, you pass on this factory thing, and the factory would create an object for you. So this is called the factory pattern. We'll look at that later on, but you can see that the creator, the abstract class here, would create an abstract product. Okay, but the actual product is created from the actual creator. Okay, so this inherit. Okay, and this is association, means like whatever it describes how class interact. Okay, like for example, we will need to understand basically two things. One is inheritance. Okay, inheritance is like inheritance, right? You have a base class here, shape, and you have a rectangle and a circle which is a shape. So you describe it this way using this kind of symbol. Okay, and another one is called aggregation. It says like you has many things. Okay, like a subject has a observer collection, so it goes this way. Okay, this one has an observer. Okay, and then an observer, and there are two concrete observer. So this is an abstract class. An observer has a method called update that that the subject can notify, and this is the actual observer. Okay, in Python, so you need this kind of like, when you look at patterns, if you use Java, you need a lot of inheritance, but if you use Python, you don't really need it. So when you read design patterns, maybe you see something that you probably don't need in Python. Like you don't need to define this abstract class. You can just pass an observer with particular method to the list, like this one, and then you can just go with it. Okay. Okay, we see more example of that. Okay, but when you look at the observable patterns, that's what you see. Okay, so we'll see how to apply this observable thing. Okay, if you recall, in the monkey game, we have this this on key press function that would be called when there's an event. Okay, and then if we have a game with many objects with that interacts with the keyboard controls, then we need to really, you know, update this function, right? And if you have a bunch of objects trying to look at the keyboard events, having the code like this is gonna be like really messy. Okay, this function will get longer and longer and longer, and it's at some point it will be extremely hard to maintain. We will fix this by using the observable patterns. Okay, so let's look at it again. Okay, the key idea of the observable pattern is that you have a subject with a collection of observer, and each observer would be called or notified when some event happens. Okay, and the observable pattern is extremely important that Java and C# have these patterns baked into the languages. Okay, so the intent is like to let an object subscribe to events from other objects, and this would decouple the event handling code from the object that generate the events. Okay, so let's see how we would do that in our monkey code. Okay, let's look at this class. Okay, so this is what's happening here. So there's a function that when the user press a key, then we check if the thing is the character of the event is something that we would like to look at, and then we would act upon it. Okay, so we can change this into using the observable patterns. Okay, so this is this is where we call the event, right? So we fixed it in game lib. Okay, this is our game lib. Okay, so instead of just calling this key press, okay, so we would register the key press observer. Okay, if you use a strict, so I'll do it in two ways. I would definitely follow the object-oriented paradigm first by only allows the user to register the key press observer as an object, and then we'll call it. Okay, and then we will change it so that you can just pass the function. Okay, and the function would do something. So previously in object-oriented paradigm, you cannot just pass a function. So you need a full object so that you can call the notified on it. But in Python, you don't need to pass the whole object. You can just pass a function, so things will be much nicer. But you can still follow the observer pattern paradigms. Okay, so instead of having this on key press and on key release, we can just leave it there. But we probably not gonna let the other people use it if we decide that the only way to hook into the on key press is to go through observers. Okay, so you have this thing, self on key. So initialize into empty set. Okay, and then here, when there's an on key press, then we'll say for server in self dot on key press observers. Then we say observer dot notify, and we pass the event to it. Okay, so this is it. Okay, you can do the same thing with on key release, but we'll do that later on. Okay, in monkey, okay, here we would need a few observers. Okay, this is the this gonna be one observer. This is gonna be like the banana start moving observer, and this would be another like speed adjustment observer. So we would need a few more classes, but you can have a class inside a class. So let's do that. Class speed adjustment observer. Okay, and in its initialization, we just pass the game app. The app. And then in the game lib, if you look at it, it's called notify with the event, right? So here you need to implement notify. Let's say, suppose we forget to do that, okay? I'm gonna keep this on key press so that we have the old code, but just throw it away for a minute. And then on the init game, I would register self dot on key press observer dot append. Okay, and then speed adjust what's the name? Speed adjustment observer. And we pass on the self to it. Okay, so this is how you add the observer into the set. That doesn't look really nice, right? So in game lib we should have this function, register on key press observer. Observer. Okay, so in our code we just call register okay, that's it. And then we create speed adjustment observer self. Okay, let's try to run it. It should crash. Okay, and it doesn't know speed adjustment observer. Okay, why is that? Because it's inside the class. Okay, so we can just call it monkey game speed adjustment observer. Okay, so let's run it. Okay, now on key press observers. Oh, it doesn't have this on key press observer. Let's see. Oh, okay, we call init game here, so we have to initialize the the thing there. Okay, now if we hit some keyboard, then it would crash because this function doesn't have it tried to call function notify, right? Method notify, but our observer doesn't have method notify, so it split out these errors. So now let's add it. Notify with event. Okay, so speed adjustment observer just basically do these two functions. You can see that we just move stuff around. Okay, it checks the character and check the speed, but now it's not self.speed, so it's self.app. So we say app equals self.app. If app.speed speed. Okay. Now you can adjust the speed. Let's say you can see that we have the speed change, but we can't throw the banana yet. So to do that, we need another observer call. So I need to just copy that and then say banana thrower observer. Let's call that. Then when the notify is called, we just check this. If app.banana is moving, replace self with an app.speed and everything. Okay, and we can just throw away this function. Now we need to register also banana throwing observer. Okay, you can see that all the observer are up here. Okay, and let's see if you can throw banana. Okay, increase the speed. Okay, so that's the thing. That's how you would use observer pattern in the classic object-oriented ways. You can also see that in the initialization here, we can have an app. This method like this duplicate codes, right? So we would do this to make things more app observer, and then we do that. Okay, and then we say app observer. Then you don't need to do the initialization because we extract the duplicate code over there. So this is the example of refactoring. So when you see duplicate codes, we just move stuff around so that it looks better, right? It's smaller code up there. Okay, and that's how you would organize the observer patterns here. Okay, now this is the classic OO style observer, and it's kind of long, right? But because you extract the whole thing into two classes here, we don't have the long event handler code, but we have this clear registration of observers here. So you can see that, okay, when the user press a key, then these two observer would run. Okay, and these two observer would do something. You can see there's something called related to speed adjustment. Another it would be the banana throwing observer. So this is the classic observer style, OO style. Okay, but in Python you can see that basically this is just a function, right? You wanna call this function, really. Okay, so so let me commit this for a minute. Okay, All right, you can see that this is just a function, right? And most of the time it's okay to just to deal with function. So we can just do this. Okay, this is not going to be an OO, like we're not going to follow the observer pattern that strictly, because you know it's an OO pattern, right? But with Python, you don't need to go, you know, just strictly do the observer thing, right? So we can just pass on a function. So we can write this so we can have this function called handle speed adjustment key press. Okay, and then here we would just take this code out. You can see that we need to again okay, we need to rename this into self. Oh, back to self, because it's just this function. So it's not good to just do it and go back. If you decided earlier what you would like to do, you don't need to go back and forth like this. But I'll show you this because it's another way to do things. Okay, here I would just call something handle banana throwing key press, and here, and then change this to self again, because it's Python. Maybe the refactoring tool might not work well. Okay, and then and here you I'm not gonna call it an observer, so I'm gonna call it handler, and then self dot handle banana speed adjustment key press, and then self dot handle. Okay, so just pass on a function. So register a function in the game lib. So this is, we're not gonna call this observer, just call handler, or maybe just functions, but it should be fine. Handlers, just call pass on function f, and then for f in self dot on key, then just call even, like that. Okay, then try to run it. Oh, it's a function f list. Oh, sorry, dot append. Okay, just append f to the list. Now you can, everything works again, same thing. But our code is like a little bit, you know, shorter, because we don't need to, we split the thing into two functions, without having to define a new class and everything, change the self and stuff, right? Okay, so we only split thing into functions and register the two functions over there. Okay, so this is more lightweight than the actual having the actual observer object and then you know, you create an object and pass the object, and the object call a method that would call another method inside our class. Okay, so this is easier. It follow the same spirit of the observer patterns. Okay, we aren't just not just pass the observer, we pass the function to that would be called when something happens. Okay, so this is also a kind of like observer patterns, but it's written with a function, a programming language Python that allows you to be more flexible about how to pass functions. You cannot do that in typically in Java and in the classic Java and other static type language. Okay, yeah, you can, like modern language, you can allow you to pass function. Like the modern Java, you can do that. You can pass lambda, you can pass functions, but at the time, when people start coming up with observer patterns in OO languages, it's really hard to do that with just standard Java. So you're required to use observer. Okay, but we can just, you know, pass on the functions, and it's easier and you know, pretty, I think it's cleaner. Okay, so this is how we implement the observer patterns. Uses just functions, okay, without having to introduce the actual observer class. Okay, so you can pick one you like, depends on I think both of them are fine. Okay, so you can do either ways. Okay, all right, we've seen how to do that. Let's go back to look at more patterns, but before we would look at more patterns, we will look at one technique that is really important for you when you write codes. This is called refactoring. Okay, what we have just done is that we have a messy code and we try to improve the code to be a better one. Okay, one way to do this is to use refactoring techniques. What I mean by better code is that the code has better structures. What I mean by better structure is like it's easier to understand, easier to change, and all the changes can be localized. What I mean by localized is that when you want to change something, you don't have to go to many places. It's gonna be at one place for one concept. So this is mean by localized. So this is what you should regularly do when you write code. When you see messy code, you try to improve it to a better code. But refactoring is a particular way of improving the code. It's a way to change the structure of the code without changing its behavior. Okay, we're not gonna add functionality. We're not gonna fix bug. We just move things around so that the structure of the code is better. So this is called refactorings. There are recipes or, you know, methods for refactorings, like many of them, and they each try to fix a particular problem in your code. So ideally when you do refactoring, you would start by writing unit tests. We haven't done that yet, and then we change the code structure, and then we would test again. Okay, so like we would extract a new class. We would, you know, from a long function, we make a new function from it. So this is what we usually do over and over again when we write software. Okay, so but when you know you should do some refactoring, or when should you do you know, code improvement, you can follow this basic thing called code smells. Okay, when your code is bad, you can say it smells. It doesn't feel right. It doesn't feel good when you look at it. Okay, and there are many code smells that you can that would help you notice that you need to. It's time to fix your code. Okay, I'm gonna follow this website, this Refactoring Guru. Okay, it has a really good content about refactoring and design patterns. Okay, so you can take a look at it. So for refactoring, it has a list of code smells here. Okay, let me. We're not gonna go over it on their website, right? You can go over it by yourself, but each of the code smell has a description and like the treatment, what should you do and why would you do it. Okay, so you can go ahead and take a look at them. We'll see it over and over again, so this is a really good website. You should check it out. Okay, it also talks about refactorings and design patterns here, like design patterns, like creational pattern, factory method, and abstract factory, and also this behavioral patterns called observer. Okay, so this is the pattern that we have just shown you how to do that. Okay, so you have a subscriber. So there are many ways to implement observable patterns. This gives you one way to do it. Okay, so it's a really good website. You should check it out. Okay. Okay, so these are the list of code smells that has been collected. Some of these are maybe it's very not easy to it's not that hard to understand, but we will look at that in more details later on. But many of them are like when you have a code that are kind of like unreadable, like long method. When your method gets too long, then you should feel bad about it. You should feel like you should fix it, because long methods are usually difficult to write and fix. It says like this method is doing too many things, so you should fix it. A large class, or when you have a function with or method with a really long parameter list, so you should feel like maybe you should do something about it. And duplicate codes as well. When you have the same code over and over again in your code in your code base, like it means like your code is very fragile to change. If you need to change something related to that duplicated codes, then you need to change it in many of the places. So it's a sign that you need to do something about it as well. Okay, so we'll look at more code smell later on, but when you see the code smell, you should think about refactoring or updating your code. We'll look at refactoring techniques pretty soon, but the one technique that we can use is to refactor into patterns. Okay, so when you see a problem with your code from the code smell, maybe you realize that, okay, maybe I can use these patterns. Then you fix your code according to that pattern. So you look up the pattern, see if it's really the thing that you want, and then you fix your code with it. Okay, so that's the introduction to the idea of the patterns. In the next video, we will look at more patterns that you can use to build your game, and we will study a few more with some examples. Okay, see you in the next clip.